Hello, algebra students. Mr. Lawrence here with some homework help for you. Now look, I know some of you say, I can't do story problems. As soon as you say you can't do story problems, you've already defeated yourself. You can't do that. Don't say, I can't do story problems. Watch, imitate, and then see what you can do. You might surprise yourself. All right, this is problem number 9 from the homework to help you out. Janet is mixing a 15% glucose solution with a 35% glucose solution. Stop right there. I know right off the top of my head she's got one vial here, and this is 15% glucose, right? And then she's got an identical vial here, only its contents are different. There's 35% glucose. If I mix the two together, my minimum number is 15%. That would mean I'm using all of this one and 0 of that one, liters we're talking, and my max number is 35%. Okay? Now, I think about this as a slider on a number line. What's going to happen? Well, my slider, let's pretend I use all 15% solution, is going to be all the way over here, right? As I add 35% solution, it's going to move away from the 15%. If I use a little bit of 35, it's only going to move a little bit. If I use a lot of 35, it's going to move a lot. It can only be here if I use all the way at 35 if I use 0% of the 15. So think about it as a slider. Hopefully this helps you out. Some of you were struggling with it. You didn't give up. Jamaica, I love how you kept trying. Think about it as a slider. I start at 15%. As I pour some from the 35% solution, I have to move further and further. If I use exactly equal amounts, I'll be exactly in the middle. By the way, what number is in the middle of 35 and 15? Well, 35 and 15 is 50, and 50 divided by 2 is 25. So smack in the middle must be 25%. So if I use an equal amount of both, I'll be smack in the middle. My new mixture will be 25%. If I use more than half for 35, then it goes up over here. If I use more of the 15%, it'll drop down here. So I start at 15. As I add 35, it creeps up, 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 up. The more I use, the further it creeps. Okay, so I need the mixture produced, I'm told the mixture produced 35 liters of a 19% glucose solution. How many liters of each solution is Janet using in the mixture? Well, what do I have to find? I have to find the liters of 15% glucose and the liters of 35% glucose. Those are my variables. Let x equal the liters of 15% glucose, and let y equal the liters of 35% glucose. Okay, I should have my first equation. I'm going to take the liters of the 15%, mix it together with the liters of the 35%, and that should give me the total liters. It's just a coincidence that this is 35 and that number is also 35. That is just a coincidence. Now, my second equation is real simple. I'm going to take the percentage as a decimal and multiply it by the liters. So I'm going to go 0.15x plus 0.35y. That's got to equal this percentage, 0.19 multiplied by 35. Now I like to cross that out and figure out what that is right away. I don't like to deal with that in an unsimplified form. So I'm going to multiply 0.19 by 35, and I'm going to get 6.65. All right. Now, was Ashley asked me to do elimination in class. So for this one, I'm going to do by substitution. I'm going to solve this equation for x. And so I'm going to subtract y from both sides. And I'm going to get x is equal to 35 minus y. Now, I'm going to take this 35 minus y, and I'm going to substitute it into the other equation. Always have to do it to the other equation. So my new equation becomes 0.15 times the quantity of 35 minus y, oop, made a silly mistake there, minus y plus 0.35y, and that'll equal 6.65, or 6 and 65 hundredths. All right, I'm going to distribute, right? And let me see here, 35, ooh, looks like I changed forms, times 15, it's going to be a 5, 2, I'm going to get 15, 20, 22, I'm going to carry another 2, 3 and 2 is 5, and then there's 2 decimal points, so it looks like it's going to be 5.25, and I'm just going to verify that real quick. Okay, I just double checked myself. I felt like I had made a mistake, but I didn't. Minus 0.15y plus 0.35y, that'll equal 6.65. Right here I have some like terms, right? There and there I've got like terms, so I'm going to put them together. And so I'm going to get 5.25 plus 35 minus 15 is 20. Don't make this hard. 6.65. And then I'm going to solve my two-step equation. 5.25 minus 5.25. And I'll end up with 0.20y equal to 1.4. So I'm going to divide by 0.2, divide by 0.2, and yeah, y is going to equal 7. 7 liters of the, which one was that? That was the 35% solution, right? Of 35% glucose. And then to figure out the other one, I'm going to take 35 minus the 7, and I'm going to get, oops, minus 7, and I'm going to get 28. And so that X is going to equal 28 liters of the 15% glucose. Now, personally, I think it makes a lot of sense that my answer ended up being way heavy to the X, because remember, my goal was a 19% solution. And on a number line, 19 is way closer to 15 than it is to 35. And so I need way more of this one than I do of that one, if you think about my number line slider idea. All right, so that's how we do a chemistry problem. Let's look at this nickel and dime problem I have here. Actually, it's nickels and quarters. Jim cleaned out the reflecting pool. Oops, that's supposed to be excuse me, right there. The reflecting pool at the library. He found 20 nickels and quarters. Hey, I think I've got my first equation. The collection of nickels and quarters totaled $2.60. How many quarters did Jim find? Well, I need to find the nickels and quarters. Only the quarters, but let's do both the nickels and the quarters in this one. So I'm going to let n equal the number of nickels, and then q is going to equal the number of quarters. So my first equation is going to be n plus q, and that's the number of nickels plus the number of quarters. Well, that has to equal 20, because he found a total of 20 coins. Now the second equation is very similar to the chemistry problem. There's one small difference. How much is a nickel worth? 0.05, right? 5 cents. So I'm going to do 0.05 n. A quarter is worth 0.25 q. Now before we do the other part of the equation, I want to point something out. Isn't this the money from the nickels? Right? Okay. And isn't this the money from the quarters. If I add the money from the nickels and the money from the quarters, don't I have to get the total amount of money? Notice there's no multiplication over here on the right-hand side. This part here is the money from the nickels. This part here tells me the money from the quarters, and that gets me the total money. Get rid of those circles. All right. So now I've got these two equations. I'm going to go ahead and I'm going to solve this one by elimination. I'm going to multiply this guy by negative 0.05 and this guy by negative 0.05. All right, so I'm going to get a negative 0.05n minus 0.05q, and that's going to equal a negative 1, I believe, negative $1. Right, 5% of 20, 20 times 0.05, yep, negative 1. Now I'm going to add my two equations together. In doing so, I'll allow these two to cancel, allow this to become 0.20q, or plainly just 0.2, and then I'll get 1.60. Okay, I'm going to divide both sides by 0.2, both sides by 0.2. Q is going to end up equaling 8. So in other words, there are 8 quarters. Now that's all the question asks, but I can't figure out the number of nickels. I know there's 20 coins in all. 20 minus 8 would be 12. There's going to be 12 nickels. And there you go. This was the answer to the question, but just to show you what we could do if they asked for both. All right, that's going to be it for the lesson today. We're going to get some more practice with this tomorrow. Mr. Lawrence signing off. Good night, everybody.